A very good day, dear students. A very good day to you. I am Shomadip, as you all know me, your faculty for robotics. So now, since we have moved further along with the chapter 1 and chapter 2, that was the introduction part and the robo anatomy, now we will be seeing the brain of the robot. Now, this is a very specific chapter in which we are going to learn about the actual brain of it. That is why it is named as such. What is the brain? What is the brain of the robot basically? It is something called a microcontroller. Okay. As the name suggests, dear students, the microcontroller, what does it do? Basically, controls, right? The controls all the actions of the robot, how to move, when to do any kind of action the robot is supposed to do, right? So it is basically, we can say, can we say it as an interpreter between us and the robot? Because the robot cannot directly understand our commands, directly understand our instructions, right? So we can say, in a way, the controller or the microcontroller that we are going to use in future, it basically conveys our message to the robot itself, right? So that is where the function of the brain comes into. So let us move further. Let us go into the chapter. Let us see what we need to study. Now, let me tell you, since we will be doing some project basis class in future, so there will be one or two types of microcontroller that I will be focusing on, since I know that that would be easier for you to learn, right? But in a basic manner, we will be covering in this session, basically, we will be covering, going through a read through, right? I'll give you some concepts. I'll give you a read through all the microcontrollers that are somewhat common or you might not know maybe in this session. Okay, so let us give it a read through. How many kinds of controllers are there? How many types we can divide them into? What are their functions? How are they different from each other? Basically, all these things. Okay, so let us begin. This is basically to define the brain of the computer. What is a brain basically? In human beings, in any animal, in any living being, it is a complex organ that serves as a control center, right? And what do we mean when we say control center? It controls, it basically facilitates all the activities of the body. That's what it does. That's what the very basic purpose of brain is, right? Any kind of action you are going through, I am teaching, right? So it's basically my brain signaling when to move my hand, when to speak, when to move my tongue, when to move my lips, when to blink my eye, when to breathe. Each and every instruction is instructed by the brain. That's it. That's all we need to just sum up about the brain. We don't need to go into great details about it. The controller. What do we mean by the controller? So if we go by definition, you see what I've done is I've written it in a very lucid manner so that you can understand that. Everybody can understand. So the controller of a robot, it is basically the central command unit. What do we mean by that? It's not a rocket science. It's not something rocket science. Try to understand. Central command unit. Central means the unified one unit, right? Okay, it's a single unit. It's a command unit. What kind of unit it is? It is a command unit. That means it gives the command. So it is basically responsible for processing the inputs. And what are the inputs? The inputs are basically the instructions that we are giving to the computer. Computer, by computer, I mean to the robot. So the instructions need to be given in a specific format, right? And that format is basically the command that we are using. So after receiving the command, what it does, it basically process all the information. What it does, it is processing all the information, processing all the inputs, all the types of inputs that it had received from me or you, anybody else. Okay. After processing, what it does, it executes. See, only processing is not enough, right? If it only processes the information and does nothing, what's its use? So basically it does three jobs. Number one, it's very easy to remember. In our childhood, we have learned in computer classes, maybe input, process, and output, right? So it's basically that on. So it takes the input, right? It is responsible for receiving the input. It is responsible for processing the input in a manner, in a format, and then it is responsible after that for executing the tasks. That is out, right? Now here you can see written something as coordinating the movements of various components. Coordination is basically a very vital part, you see, because any kind of movement, any kind of activity in a robot must be coordinated. And that is where the one of the main purpose of the robot comes in, the coordination, right? Precision, accuracy. We've learned all these terms. We have defined as the purpose why robots and all in the introductory session if you have attended it. So these are all the functions which basically the brain of the robot, that is the controller, does, right? What does it connects? It is basically connected to the main parts, like the actuators can be there, like the sensors can be there. Okay, all these parts, they are connected to the robot via somehow or the other, directly or indirectly, they are connected to the microcontroller. Now, types of microcontrollers. Now, I've already said, I've already mentioned that we'll be giving it a read through. Okay, we don't need to get into great details about it because we'll be using only one or two types of the microcontroller in the future projects. Okay, so it depends upon the projects, it depends upon the person to person, organization to organizational requirements. Okay, so now I hope you have the idea of bit, byte, kilobyte, megabyte. We all like recharge our mobiles with 1 GB per day, 2 GB per day. So gigabyte, GB, right? These are the memory units. I hope you all are accustomed with. Now you see how it has been classified into very basic classification method. Number one, 8-bit microcontrollers. Number two, 16-bit microcontrollers. Number three, 32-bit microcontrollers. Number four, ARM microcontrollers or ARM microcontrollers, basically. Number five, PIC microcontrollers. Number six, AVR microcontrollers. Number seven, FPGA-based microcontrollers. What are they? We'll be getting into them very in a very lucid manner so that everybody can understand and have a basic understanding of what kinds of microcontrollers are there and how to distinguish between them. That's it. That's all my purpose for this session is. Okay, let us move ahead. First, if you say 8-bit microcontroller, so these microcontrollers, they are the most basic types. Why 8 bits? They work in bits. Bits are the most smallest unit of memory unit, we can say bits. Okay, 8-bit from a byte. We all know that. We have studied all these things, right? So these are the most basic types of microcontrollers, and they are being used in simple applications. How? In toys. You've seen some of the children's toys, they strike a surface, comes back, like these kind of simple operations, right? 8-bit microcontroller is more than sufficient for them. Okay, very small appliances. Okay, and very easy to use or cheap remote controls that we have. 8-bit microcontrollers. Okay, since they are 8-bit microcontrollers, so the memory space, memory allocation, the power of processing of information, they are very small. Rather, I should say they are the smallest among all the microcontrollers present over here. Okay, and they are very cheap also. That's the reason. Fine. I hope you got my point, what I'm trying to say. Then comes the upgraded version of it, 16-bit microcontrollers. Okay. So 16-bit microcontrollers, they are a bit more advanced than 8-bit microcontrollers. Obviously, that is the reason why they have been developed, right? Okay. They are basically capable of performing a bit more complex tasks than the 8-bit microcontrollers. That's the thing. Okay. Where they are used, they are commonly used in medical devices, small medical devices, right? Automotive systems, okay, and also in industrial control system, smaller industrial control system. This is where a bit of complexity arises. Okay. After that, obviously, after 16, it will be 32-bit. And where are they used? So these are the most powerful and feature-rich microcontrollers. So they can be programmed and reprogrammed or reprogrammed in such a manner so we can add many features into it by using this kind of microcontrollers. So they're capable of handling large amount of data, obviously. Okay. And they also perform very high speed performance they give, because the memory allocation is distributed in an even way and the memory allocation is also more. Okay. Understood? In some of the gaming systems and devices, they are used. So this was about 8-bit, 16-bit, and 32-bit microcontrollers. Now we'll be going into a bit more advanced system, ARM microcontrollers. Okay. So these microcontrollers, they are basically based on the ARM architecture. Okay. So what are these ARM microcontrollers basically? So they are some kind of advanced RISC microcontrollers. Okay. Now you might ask, sir, what is RISC? So they are basically reduced instruction set computers. Let's not go deeper into that. Okay, because we are not going to use it anyway. Okay. I mean, many kind of automotive systems and mobile devices, these are being used basically or specifically for the industrial purposes. All right. Then comes the PIC microcontrollers. Okay. All right. So these microcontrollers are manufactured in the microchip technology. Okay. All right. So they are basically the, we can say, if you want a full form, it is basically the peripheral interface controller. So again, let's not go deeper into this. Now, what are the applications? You must know the applications basically. So they have a wide range of applications. You can like more than ARM microcontrollers, PIC microcontrollers are widely used in the industries. Okay, in kind of medical devices, complex medical devices, right? And then comes the AVR microcontrollers. So these microcontrollers they are basically manufactured by the Atmel Corporation, okay, and are commonly used in applications such as robotics, like general basic robotics, industrial control systems, and consumer electronics. Okay. So these are all about ARM, PIC, and AVR microcontrollers. Okay. Let's move further and let us know about some other kind of microcontrollers. FPGA based microcontrollers. So they are basically the field programmable gate arrays, which the acronym comes from FPGA. Okay, field programmable gate arrays. Now they are basically used in high precision, right? What do I mean when I say high precision work? They are basically used to provide highly customizable and flexible processing unit so that you can customize it based on your requirements. Okay, there are many industries, there are many operations which requires constant customization, right? And you can do that using FPGA based microcontrollers. So I hope it is clear to you how we can classify it based on the usage, based on the memory usage, based on the memory allocation, based on the memory space. All these factors matters. That is how we classify the microcontrollers based on that. And that's it. That's it. That's all you need to know about these things. And we can go further and we can study about the major parts in a microcontroller. In a microcontroller board, small board, if you see, for example, you can take the very basic example of an Arduino Uno, maybe the most famous one that we'll be working for. First of all, the CPU, of course, it's the central processing unit. We all have learned the full from, it used to come in our examination, right? Okay, in our childhood. So the microcontroller is referred to as the CPU device. Why? Simple reason. It is actually the central processing unit of the robot, right? All right. All microcontroller components are connected to a specific system utilizing a central processing unit, right? So it can basically decode the instruction and process it. Okay. After which comes the memory. This memory part is very important because it is the primary reason why we distinguish between so many kinds of microcontrollers and right. So the memory chip of a microcontroller, it functions similarly to a microprocessor in that it stores all of the data as well as the programming that we are doing currently. Okay. How we will be programming it? The microprocessor will store it in themselves. The microcontrollers, they have a limited quantity of RAM or ROM, that is the read and write memory and read-only memory, or flash memory, by which they can store program and outsource the source code. Right? That is where the function of memory or microprocessor comes in. Okay. I hope it's visible now. After that, there's the input and output ports. Now, the instructions will be processed fine, but how will we get the instructions to the microcontroller and or the microprocessor, and how will we get the output from it? And for that purpose, for that reason only, there's the input and output ports given. Okay. Then comes the serial ports. What do you mean when I say the serial ports? Serial ports are used to offer the serial interfaces between the microcontroller and the range of additional peripherals. What do we mean when we say additional peripherals? They are basically, they can be the sensor, they can be the shields, like motor shields. You will be learning, I'll be telling you about motor shields in the further classes. Okay. So that is why serial ports are needed, one after the one. Serially they are connected. Then comes the timers. Now, timers and counters are included in a microcontroller. Why? In a microcontroller, if you see, they are used to manage all timing and counting activities. See, how can we execute depends on the program. Fine, well and good. But when to execute that? That is what the function of the timers. Okay, you can see here, you can read it out here. The fundamental function of a counter is to count external pulses, that is the input that is being received, whereas timers conduct clock tasks. Many tasks include the clock, many program, many functions. Pulse production, okay, modulation, to modulate the width of the pulse. That's what we call the PWM, pulse width modulation pins. We'll be studying that in Arduino chapter. Frequency measurement, how many times it is occurring, and oscillations, among other things. And these are all the purposes of the timers present in the. After that, we have analog to digital converter. One of the most important part, one of the most important function, one of the most important things to do when we build a robot. Because every device or every sensor, they will basically work on either analog signal or digital signal maybe. Now we need to have a particular system. We need to have a system where by which using which we can convert one signal to the other. Let us read it out. ADC, that is analog to digital converter, is an acronym for, of course, analog to digital converter. The primary function of the ADC is to convert analog signals to digital signals, and the required input signals for ADC are analog, and that is why the required output that we get basically is digital. That is why it is ADC and not the other way around. Then the second last thing, control interpretation. Now this controller is basically used to provide delayed control to a running application with internal or external interpretation. Right? It can delay, it can take more time, and then it will apply over there. All right. Okay. There can also be some blocks with some of the special functions given to the controller, given to the microcontroller in some cases, right? These were all the major parts of the microcontrollers. Let us quickly have a look, quickly have a read out about the microcontroller properties. Number one, as you can see, they are devices and capable of having words longer than 64 bits. Fine, because nowadays not any kind of information we measure in KB or anything, right? We need higher versions. and memory units. Okay, all right. They consist of RAM, ROM, timer, IO ports, all these functions, right? So timely occurrence, frequency distribution of all the like inputs can be done. Okay. The ROM is used for program storage, and RAM is used for data storage. Fine. So where the programming gets stored, the program or the algorithm that we are giving, we are providing in the ROM. Okay. And where does the data, the test cases, the results get stored? In the RAM. I hope it is clear to you. Okay. CISC architecture is basically used to design it. Okay. And the latest feature of microcontroller is flash memory, like the EEPROM or EROM. Okay. So the EPROM and EEPROM, like EEPROM, they are the latest version. Okay, of the flash memory style. So this was about the properties of a microcontroller. Let us move further into the next session. Okay, we'll be studying in more details into a very specific and particular topic. And what is the topic, dear students? The topic is, since we will be moving into Arduino, we need to study Arduino in details so that we can build up the projects. So in the next sessions, we'll be going into the IC, that is the Atmega 328, and also after that, we'll be going into studying Arduino hardware first, basically, very important, and then we'll be moving to the programming part. So that's it for today. I hope you have enjoyed the session. We will again meet in the next session very quickly. Thank you all of you.